So here you could see the air conditioning unit which is blowing the air conditioned air, and that air is passed to the HEPA filter. And in the HEPA filter, the dust and dirt is removed, and we have a clean air. And these are the air conditioning system where the air is cold and then it is circulated, recirculated inside the clean room. These would be the equipment, some of the equipment, remote equipment, which would be used inside the clean room. And this is the utility distribution system, meaning that the electric power system, which would be needed for different equipment inside the clean room. Clean room, changing room. So initially, when you want to enter the clean room, so first you have to change the dress. You have to put the coverall, and you should put the proper clothing. Otherwise, you would be not allowed inside the clean room. The clean room is under the surveillance 24 hours. It would be under the surveillance of a clean room in charge of manager. Cameras would be more installed inside the clean room, and he would be actually watching each and every person, and he would be watching each and every activity through his laptop. The reason? Because the users would be using the hazardous or dangerous chemicals and solutions, which would be very, very harmful. For each process, there is a standard procedure. If you are violating that procedure, then that manager would actually alarm you. He would call you and inform you that you have to use the process standard procedure. SOP, you have to follow the SOP. So here you see that first, as you enter, this is the bench to, on which you have to sit. This is the clean side of the, this is changing room. So normally through this bench, we divide the changing room into two portions. This is the clean side and this is the dirty side. So here on the dirty side, each person or each user would have its own shelf where he could put his shoes or these shoe covers. So first you have to put the shoe covers and you have to come on this side. And then you have to put the coveralls and all other things. As I told you that when you are entering, the changing would start from the top. First you have to put the head cover or hair net, uh, mask, coverall, and then the shoe covers, gloves, etc. And then you have to enter the clean room. Clean room is normally divided into two portions. One portion is known as yellow room, whereas the other portion is known as white room. These are the pictures of yellow room. In yellow room, actually, we are using a yellow light. As you see that the light that appears to you is yellow. The reason is that the white light contains the ultraviolet radiation. The white light normally which we use inside our room, that is white light. It contains ultraviolet radiation. And ultraviolet radiation could harm your fabrication process. Because normally during fabrication we would be using photoresist. Photoresist is highly sensitive to UV light. It cures the UV. The ultraviolet radiation would cure the photoresist. So normally, in order to keep your photoresist away from the ultraviolet radiation, so we would be using yellow light, which doesn't contain the ultraviolet radiation. So all of the fabrication is done in the yellow room, which doesn't contain the ultraviolet radiation. The room is completely packed. No sunlight can enter inside the clean room because the sunlight also contains ultraviolet radiation band and it could ruin your fabrication process. So it is a complete dark room. In other words, you could see that it is a complete dark room. You have to only use the clean room yellow lights to see and do the fabrication. This is one of the pictures which I took when I was doing fabrication inside the clean room when I was doing my PhD here in University of British Columbia. Went to Canada. So I also did some microfabrication in the clean room. This is the manager of the clean room. He was very hard guy. All the time he was watching us through his laptop, and you could see that we are completely covered. You have to write your name here. So you cannot recognize people from the face. So you have to write your name, or either you have to put the badge. So this is me. I have completely covered my ears, eyes with the goggles, mask, etc. And we are inside the yellow room. The other portion of the clean room is white room. In white room, actually the light is white, uh, uh, meaning that the light contains the ultraviolet radiation. There we would be not doing fabrication. In the white room, you could do other certain processes. For example, after the fabrication, you could inspect your wafer, you could characterize your wafer, you could characterize your thickness of the layer, etc. So there would be other equipment. You could perform a certain of processes there, which doesn't involve photoresist. So those processes could be done in the white room. Some more pictures of the clean room, commercial clean room. So here you see that this is a commercial clean room. You could see the HEPA filters. These are the HEPA filters. Air comes through the HEPA filters, and then it goes down to these vents. These are the vents to which the air goes down, and it would be recirculated again after passing through the air conditioning unit. Here you see these two persons are working in the white room side of the clean room. Next slide is how large particle is tolerable. Example 0.5 micrometer CMOS technology. All technology has 0.5 micrometer CMOS technology. Lateral dimensions, pattern size 0.5 micrometer. Pattern tolerance 0.15 micrometer. Level registry. That is, in microfabrication, we would be doing fabrication layer by layer. Level registration means layer by layer fabrication. The minimum thickness of each layer in this technology is 0.15 micrometer. Vertical feature, gate of side thickness 10 nanometer, field of side thickness 20 nanometer, film thickness is 250 to 500 nanometer, junction depth 50 to 150 nanometer. Meaning that we are working in a very small dimension. It is 0.5 micro-size CMOS technology means the minimum lateral feature size is 0.5 micrometer. The minimum lateral feature size is 0.5 micrometer in that technology. So for example, a small size dust particle size, even 1 micrometer dust particle size could ruin your fabrication. could ruin your fabrication. A human hair with 100 micrometers, it could ruin your fabrication process. It could ruin your device. So, meaning that it is not tolerable to have dust particles inside the clean room. Which class of clean room you need? It depends upon your technology, what you are fabricating, what is the minimum feature size, what are the minimum dimensions. So if the minimum dimensions are very small, then you need a high class rating clean room. If your sizes are big, if your device is big, so meaning that you need low class clean room. Clean room air filters, high efficiency particulate filters. HEPA. HEPA stands for high efficiency particulate air filter. Most common type of clean room air filter. High efficiency, low pressure drop, good loading characteristics. Uses glass fiber in a paper-like medium. We are making filters which would have a filter, and how that filter is made, they are using glass fibers which are randomly oriented in a paper-like medium to have these filters. Are rated by their particle retention. A true HEPA rated filter will retain 99.97% of incident particles of 0.3 micrometer or larger. This is the definition of the HEPA filter. It would stop 99.9% of the incident particles of 0.3 micrometer or larger. So only it would allow 0.03% of the particles which are 0.3 micrometer or larger. It would stop the maximum amount of the particles. Here you see the cross section of a typical HEPA filter. You could see that we have a number of filters, continuous sheet of filter mediums, this is sheet of filter mediums, and this is the aluminium separator, filter sheet of randomly arranged fibers. These are the fiberglass. Fiberglass fibers are arranged randomly. And here the process is shown that how it retains or stops the particles from entering the clean room. One of the method is interception. So this is a fiberglass and one of the particle is coming and it is hitting the fiberglass and it is intercepted, so it would stop. Direct impact, some particle would have a direct impact with the glass fiber. And some particles would be very, very small and it would diffuse inside the glass fiber and it would be retained. So these are the different ways in which that retention is done with the HEPA filter. And dust particles are removed from the air which is coming into the cylinder. These are the images of the actual HEPA filter which has to be installed inside the clean room. These are the images of the air filters, which is made of glass fiber. So you could see the glass fiber in a paper-like medium. This is the microscopic image, 500 micrometers. You could easily see the randomly packed glass fiber, which are used to remove the dust and dirt particles from the air. Characteristics of clean room: air recirculated through HEPA filters with about 20% makeup. 20% fresh air is added in the circulated air inside the clean room. Vapors are entertained, so contamination potential is very high. Why we are doing makeup? Because we are entertaining dangerous gases, vapors, fumes. So the contamination potential is very high. So we have to add up fresh air in the recirculated air. There should be extensive gas detection system. Alarm system must be installed inside the clean room. Fire alarm system, dangerous gas detection system, etc. Temperature is controlled and it is between 68 to 72 degree F. Humidity is controlled and it must be between 40 to 46% relative humidity. Room is held at positive pressure. The clean room is contained at positive pressure. So that because if it is at negative pressure, then the air from outside would enter inside the clean room through door cracks or holes. So, and that air which is coming directly inside the clean room through air doors, air cracks, and also when we open the door, the air comes inside the clean room. So normally, if it is at a negative pressure, then all that air would enter inside the room. That air would be not clean. It would have dust and dust. So normally the standard procedure is we have to keep the clean room at positive pressure, slightly higher pressure than atmospheric pressure. So when you are about to enter the room, when you open the door, then the air would not enter from the outside into the clean room, but clean room air would go out into the atmosphere. So that way, no dirty air would enter inside the clean room. So the typical pressure that is normally maintained inside the clean room typically 0.1 inch of H2O for class 100, class 1000, and class 10,000. Typically 0.3 to 0.4 inch of water to the pressure head, inch of water for class 1 and class 2. Positive pressure constantly blows dust out. Biohazard rooms operate at negative pressure to keep bugs in. On the other hand, the biohazard rooms where we are working with the dangerous bacteria, viruses, and you are making toxic chemicals, so they are maintained at negative pressure. Reason, we don't want that those bugs, dangerous bugs, virus, bacteria, that when you open the door, they go out of the room. So when you open the door, in that case, the air from the outside will enter the room, but the room air will not leave the room. So that's why the biohazard rooms are operated under negative pressure. Doors open inward, so room pressure closes them shut. 0.1 inch H2O. 0.1 inch of water is 3.6 into 10 raised to the power minus 3 psi, or 0.52 pounds per square feet. This produces 9.1 pounds force on a 7 foot by 30-inch job. Also in the clean room, we would have laminar flow benches, and normally you have to work inside the laminar flow bench. This is the cross section of a laminar flow benches, and you could see the photograph. This is the photograph of a laminar flow bench. Here we have to work. Here you have to work. You have to do your fabrication inside the laminar flow bench. So this slide is about the laminar flow benches. A HEPA filter used to provide local clean air condition can usually drop the class rating by 2 decades within a local area. Laminar flow benches. In the laminar flow benches, we would also have filters, HEPA filter. And in that HEPA filter, the clean room air would pass. So when the clean room air passed to the HEPA filter of a laminar flow bench, the air would further clean the air, and we would have a more clean air inside the laminar flow bench. So HEPA filters, which are there in the laminar flow benches, are used to provide local clean air conditions. Can usually drop the class rating by 2 decades within a local area. Within the local area of flow bench, laminar flow bench, we would have more clean air. The clean class rating would be decreased by 2 decades. 2 decades means by 100. You have to divide by 100. For example, class 100 local environment within a class 10,000 room. If we have a clean room, its class rating is 10,000, and you have a laminar flow bench, so you have to divide this by 100. So if you divide this by 100, you would have 100. Inside the laminar flow bench, the class rating would be 100. It would not be 100,000. Designed to minimize turbulence, which creates dust and dirt collection pockets. Vertical style used above freestanding equipment and load zones, and horizontal style used behind microscope and inspection benches. So there are two types of laminar flow benches, vertical type and horizontal type. We will discuss those in the coming slides. Here you see the vertical. This is the vertical laminar flow bench, and this is the horizontal laminar flow bench. In the vertical laminar flow bench, this is the blower. Here we have the air filter. Air is coming. This air is coming from the clean room. 10,000 class room rating. And when it passed to the HEPA filter, which is the HEPA filter, the class rating would change. It would change by 2 decades. You have to divide it by 1,000. So here we would have 100 class rating clean air, and it would be blowing in the downward direction. And in this type of laminar flow bench, you have to do fabrication. You have to fabricate your device. You have to spin coat the photoresist. You have to do the baking. You have to do the etching, and that air is normally then get out of the flow bench. The air would be not flowing or blowing onto your face, because here we are dealing with toxic chemicals, and the user would be standing here. The user would be standing here. It is designed in such a way that the air blows on your wafer, and your equipment which are inside the under the laminar flow bench, but that air would not come on your face. On the other hand, this is the horizontal type laminar flow bench. The blower is here, the HEPA filter is here. The air from the clean room would pass through the HEPA filter, and it would be blown in the horizontal direction, specially designed. Here you have to do the inspection. Once you do the fabrication here, and you have to come here and you have to inspect your fabrication here. And when doing inspection, air should be blowing in this direction. Because when you are doing inspection, you would be breathing, and if you breathe on your wafer, it could ruin your device. Because when we are breathing, and if you remove the mask and you are breathing, and the vapor or saliva, particles of saliva fall on your wafer, it could ruin your product. So you have to do the inspection here. The air is blowing like in this direction. If any vapors or saliva particles are coming out of your mouth or nose, it would not fall on your wafer. It would be blown out or blown away from the wafer. So that you have to do, the inspection you have to do under the horizontal laminar flow bench. This is the cross-section view of a horizontal laminar flow. The air is uh, sucking by this blower. This is the HEPA filter, and it is passed through the HEPA filter. Here you have a more clean air. This is the photograph of an actual laminar flow bank, horizontal laminar flow bank. This is the control panel. Here behind you would have a blower. In front here you would have a HEPA filter. And this is the laminar flow bank vertical type. Fume hoods. Also in the clean room we would have fume hoods. Fume hoods are used when you are working with dangerous acids or bases, or you mix different solutions where dangerous vapors are produced, which is very, very harmful for the users who are working inside the clean room. So you have to do those processes or fabrication inside the fume hood. In fume hood, we would have a blower which would be sucking the air from the clean room, and that air would be exhausted outside the clean room through the chimney, etc. And also there would be a weaving glass. This is a weaving glass. Initially, when you have to put all of your stuff here, and then you have to drop this weaving glass. Only your hands would be inside the fume hood, and you have to perform the fabrication and all our processes, and all of the dangerous fumes which are producing or vapors which are producing, it would be sucked by the blower of the fume hood, and it would be thrown out of the clean room. So neither of the user or the people who are working in the clean room would face those fumes which are very, very harmful. Here you could see these guys are working in the fume hood. This is the weaving glass. So initially you have to lower down this weaving glass, and only your hand would be inside the fume hood, and you have to deal with the dangerous chemicals which could produce harmful vapors or fumes. That fume would be taken out directly from the fume hood into the environment or atmosphere. Again, you could see here that a lady is working inside the fume hood. With that, I'm finishing the lecture. If you have any question, you could ask, or if you want to discuss anything, we could discuss.